Okay, today we're going to talk about Unit 2, Lesson 1, Real Valued Functions Activity. This could have been attempted on your own. Some years we have our students do this on their own. But we're going to walk through it today with this short little video. The following demonstrates the basic addition, subtraction, multiplication, and division properties of real valued functions. If we consider two functions f of x and g of x, this notation f plus g of x is just equal to f of x plus g of x. This is more of a notation creature than anything else. This video is more about the notation. And then, of course, then this f minus g of x is f of x minus g of x. F of x divided by g of x, f divided by g of x is simply f of x divided by g of x, provided g of x does not equal 0. So we would have to look at, to make sure that this thing is defined, that g of x does not equal 0. And then f times g of x is f of x times g of x. This is not to be confused with f circle g of x. This is the composition, and we're going to discuss that later. Okay, so let's just do some examples. So we're going to let f of x be this linear function, and we're going to let g of x be this square root function. And we want to find the following: f plus g of 1. And we're going to simply write this out, first of all, that this is going to be f of 1 plus g of 1. F of 1, and we can figure these out off to the side if you want. F of 1, we're going to put 1 in wherever we see x. It's going to be f4 times 1 minus 5, which is negative 1. 4 minus 5 is negative 1. And g of 1 is going to be the square root of 1 plus 3, which is the square root of 4, which is 2. So therefore, f of 1 plus g of 1 is simply going to be negative 1 plus 2, which is equal to 1. And I'm going to jump right down here and do this g plus f of 1. This is going to be g of 1 plus f of 1. And we know from above that g of 1 is 2. And f of 1 is negative 1, and this is also equal to 1. And addition of real valued functions is commutative, i.e. f of x plus g of x is certainly equal to g of x plus f of x. Addition of real numbers is commutative. Multiplication of real numbers is commutative, but subtraction is not commutative. All right, so let's go to this example here, f minus g of 4. This is going to be f of 4 minus g of 4. And let's find these values. We'll go f of 4. F of 4 is going to be 4 times 4 minus 5. That's going to be 16 minus 5, which is 11. Please check my arithmetic and make note, throw something at me if I get some arithmetic wrong. And g of 4 is going to be the square root of 4 plus 3, which in this case is simply the square root of 7, which does not simplify. So f of 4 is going to be 11 minus square root of 7, and that is our answer for f minus g of 4. Let's go f plus g of negative 4. We will use green here. This is going to be f of 4 plus g of negative 4. We know what f of 4 is, or no, f of negative 4, sorry. And f of negative 4, we'll go down here with it. F of negative 4 is going to be negative 16 minus 5, which is negative 21. So the negative 21 is going to go in there. And if I look at g of negative 4 up here, let me see if I have some room down here, and I do. G of negative 4 is going to be the square root of negative 4 plus 3, which is the square root of negative 1, which is not a real number. So right away, I can say this actual addition is not defined because this guy here is not defined. So this dude here is not defined, and that makes this whole thing not defined. Negative 21 plus something that's not defined is certainly something that is not defined. Okay, so we're going to go f times g of 1, and we know f of 1, and we know g of 1. This is going to, we're going to write this as f of 1 times g of 1, and f of 1 is going to be negative 1. G of 1 is 2, so this is going to be negative 2. G of f of 5, g divided by f of 5 is simply going to be g of 5 minus or divided by f of 5. I'll put that right in there since we're running out of room. And g of 5 is going to be the square root of 5 plus 3, which is 8. And f of 5 looks like it is going to be 15. And that is certainly defined. Moving right along with the next example, we have f of x, again a linear function, and g of x, a linear function. And f plus g of 1 is simply going to be f of 1 plus g of 1. And I'm just going to put f of 1 right in there and believe that's going to be negative 9, is it not? And g of 1 will be 5. This is going to be negative 4. And I think you can see where these values come from. If I make an arithmetic error, please let me know. And f minus g of 4 is going to be f of 4 minus g of 4. F of 4 is going to be negative 15. Putting 4 in that, negative 2 times 4 is negative 8, minus 7 is negative 15. And g of 4 is going to be 14. And that's going to be negative 29. F times g of 1. This is the notation that we're going to be looking for right here. This f of 1 times g of 1. The answer is going to be unimportant. It's knowing that this means f times g of 1. F of 1 times g of 1. And f of 1 we can see is obviously, we already figured it out. It's going to be negative 9. Multiply by using the parentheses. And g of 1 is 5. So that's going to be negative 45. And g divided by f of 5 is going to be g of 5, which I have not found, divided by f of 5. And that is going to be g of 5 will be 17. F of 5, is that negative 17? 2 times 5 is negative 10 minus 7. I believe that, is that correct? Did I make an error? We good? Okay, so here is something that we've not done yet in this particular example, and this is f plus g of x. So this is simply equal to f of x plus g of x, and we're going to simplify that. So we have f of x is going to be negative 2x minus 7 plus g of x, which is 3x plus 2. That is going to be x minus 5, just adding like terms. And if you notice, if I wanted to evaluate f plus g of 1, I could actually find out abstractly what f plus g of x is, which is x minus 5, and then put the 1 in, and I would get a negative 4 there. G times f of x. A lot of people get slipped up on this example. This is going to be 3x plus 2 times f of x, which is negative 2x minus 7. And we're going to simply use the FOIL method or distributive property, whatever you prefer. This is going to be negative 6x squared minus 21x minus 4x minus 14. And simplified, that's going to be negative 6x squared minus 25, sorry. Minus 14. I believe that is correct. And I think, if I am not mistaken, that is it on that. So my question to you is, would you like another example? I think you have a blank page of finding this. We are still videoing. Would you like another example? Okay, so let's consider, and I'll do a problem similar to what's on the assignment. So let's look at this function right here. Negative 2x squared plus 3x minus, I don't care, 5. And I want to find f of x plus h. What I'm going to do is, wherever I see x, I'm going to put this x plus h. The x plus h is the input of that function. So this is going to be f of x plus h is going to be negative 2 times x plus h squared plus 3 times x plus h minus 5. All right, so the first part that we have to do, and it might be a good idea, I'm going to figure out what this is, x plus h squared. We can't forget that x plus h squared is the same as x plus h times x plus h. And I'm just multiplying two binomials here. That's going to be x squared, x times x, woo, 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 x times h, which is plus xh, h times x, whoop, whoop, which is also x plus h, or h times x, because multiplication of real numbers is commutative, plus h squared. And if you want to just say, hey, that's x squared plus 2xh plus h squared, you certainly can. You don't have to, but that's what this is right there. So I'm going to have to put that in there. And keep in mind, we're going to do this a lot next year. Well, not a lot, but we just went over that and students struggled with it because it's so heavy analytical. So f of x plus h is going to be negative 2 times this whole kit and caboodle. I think I went through this example quick yesterday. Plus 3 times x plus h minus 5. Now I'm just going to distribute the 2, the negative 2. This is going to be negative 2x squared minus 4xh minus 2h h squared plus 3x plus 3h minus 5. Hello?